So we touched on the Ethernet uplinks now, and we touched on the fiber channel uplinks. We touched on the blade networking side. So I now want to focus on how everything comes together in configuring servers. So the initial thought of the UCS system was that we need to have a stateless system. So we cannot have any kind of state information on the hardware itself. That was the initial design thought when designing the UCS system. What this means is, what is a state information? Well, first of all, every server on its motherboard has a UUID, right? So every server contains a UUID. So let's first make this configurable. We have things like BIOS settings and stuff, or any other kind of setting that I need to do manually into that type F2 to get in that blue screen and type in all kinds of settings. Those settings, I probably want to manage that. Also things like the boot order and stuff. I want to manage this through a nice GUI instead of just connecting my screen and connecting a keyboard to the server and then doing that all manually. I want to have this controlled in a management environment. But take a look at other things that we have. We have an installed operating system on the server. That's the biggest issue, right? We install an operating system either on local disks or we boot from SAN, but either way, those settings and that OS is connected to the data in the server. So if I install Windows or if I install ESX, I know what the UUID of the server is, and most importantly, what, for example, the MAC addresses of my Ethernet interfaces are. Because ESX internally connects a NIC on the PCI bus with a certain MAC address to a certain VM NIC name. And that VM NIC name is then important for when I'm doing settings in my ESX. For fiber channel, that's even more necessary for the worldwide port name. I probably have my zoning and my device aliases set up with the correct worldwide port name. So if I'm going to replace the server, that's going to be an issue because I need to change zoning stuff. And of course, worldwide node names with that. And all other things that you can think about that is considered state information on the server. So the issue was, so the design thought was here, we want to make sure that if we take this group of settings, we want to take these settings and reapply them on other hardware boxes. So this state information, this is what we want to reapply to servers over and over again. So what they said was we decouple a list of settings. So all these settings, like MAC addresses on the network cards, worldwide port names, and with the Palo card even how many VNICs do I want to create and what VLANs should be allowed on those VNICs. All that configuration is considered a XML file of settings or just a list of settings, and we want to apply that to a piece of hardware. In our case, an Intel server with just a few CPUs and some memory and some network interfaces. So we take the settings out of the hardware and we manage them separately. That's what we do with UCS. So if you start looking at your equipment tab, or I cannot show you that of course. So if you take a look at your equipment tab, that's where I see just the hardware components. If I click on a server, I cannot do any changes on of the settings. If I do not specify anything in the UCS manager, my servers, I cannot power them on. So by default, I always need to do settings on the servers before I can start working with them. So servers are powered down when you start up your UCS, and I do need to do some settings to, let's say, all right, you use this setting, you use that setting, and then you can power on the server. That list of settings is called a service profile, or SP for short. So that service profile contains all the information, so all of the UUID address, all of the MAC addresses for the interfaces, the worldwide port names, the BIOS settings, the boot policy settings, all the settings that I need to power on a server, that's what I contain into a service profile. So I do not mean mappings, no, I mean actual addressing. So if I take that list of settings, I have an actual UUID configured here, 1, 2, 3, 4. I have an actual MAC address configured here, A, B, C, D, and so on and so on. So I have actual settings listed in the service profile. Now what does this implicate? This implicates that one service profile can only map to one server, right? One piece of hardware can run with this particular UUID and with this particular MAC address. So a service profile is not something you can reapply over and over again to all of your servers. No, one service profile maps to one server, to one piece of hardware. Now, of course, there are many ways to use all kinds of templates and policies to make sure that I can reapply a certain list of settings over and over again. But a lot of people think that a service profile can be just reapplied to a lot of servers. No. Service profile contains the actual settings that need to go into the server. And that is what I apply to that piece of hardware. That list of settings maps to this particular piece of hardware. And that mapping will stay in place at all times. I can change this. So I can say, remove the service profile from the server. So that means I free up the resources and apply that now to another piece of hardware. So I can take any server in the system and move a service profile over like a vMotion. It's not a vMotion because I need to wipe all the settings from this piece of hardware and apply those settings to that other hardware, but I can move my settings between different servers. But it's not a template because I list those actual values. I do not list, let's say, a list of settings. No, I list exactly the addresses that I want to apply to that piece of hardware. So that what UUID is only once specified in the service profile. Now, of course, we want to have some kind of template, right? We want to reapply basically the same settings to basically the same servers. I mean, how much difference do you have in your ESX servers, right? Your ESX servers are all configured usually mostly the same way. So, of course, we can make service profile templates. And that template will list all kinds of more globally defined things to reapply. So let's say I do not specify an actual UUID here. No, what I do here is I configure things like a pool of UUIDs that can be applied to the servers. So I specify like a DHCP pool, but then for UUIDs. So a template, a service profile template consists of, for example, pools. And in that pool, I will have a list of UUIDs available, a list of MAC addresses available, a list of IP addresses for iSCSI boot available, a list of worldwide port names available, and think of anything else that I can get a list of. So resources that I need to allocate to physical components. Now my BIOS settings, for example, those will probably be the same on all of my ESX servers, right? Because I am running the same type of processor, so do I want to enable hyper-threading or not? Or think of a list of things that you set in the BIOS, right? Serial over LAN stuff, all that stuff will be basically the same thing. So I can use a template for that as well. Now, templates are things that you can change over time, right? There may be some things that I can change in my service profile that I need to change on my servers. Of course, the BIOS settings will not change a lot, but maybe I want to insert a new network card because I'm connecting to a new DMZ network, for example, doing my disjoint layer 2, so I need additional network cards. So I need to update my service profile template then. So templates can be updated. BIOS settings technically cannot update because what they use is what's called a policy. So a policy is also kind of like a template, but a more fixed version of it. So once a policy is applied, I will not update the policy when this policy is changed. So in this policy, I determine just fixed settings, like do I want to enable flow control on the links? Do I want to enable CDP on my network cards? All that stuff, all those fixed settings, I can create a policy for that and apply that once to my template, and then it's there forever. If I change the setting in the policy, it's not going to be automatically applied to the template where it's using that policy. I need to create a new policy for that and apply that. So these are more fixed versions. Templates are dynamic, depending on how you create them. So templates, pools, and policies are my most important parts in the configuration of my UCS. Now there are two types of templates. There is an initial template and there is an updating template. The updating template is what it does, right? Is what it says. So I apply settings to a piece of hardware, and I apply that multiple times. So I create from a service profile template, I create multiple service profiles, right? To apply to all my physical servers. Let's say 3 servers. As soon as I update a setting, let's say I change the BIOS settings, right? I do a change in the template. This change is then automatically applied to all of the service profiles that are connected to the template. That's what an updating template does. The initial template is doing the exact other thing. So I apply all the settings. So I create 3 service profiles out of that template. And after that, I forget that the template even exists. So these service profiles are now independent. So if I now change that BIOS setting, these profiles that were initially created will not take that new setting anymore. There are situations where you would want to use an initial template or an updating template. Because of course, if I do wrong things here, I could set wrong settings on existing servers. So that means that I can get into issues when I apply those wrong settings automatically to all my servers. So the advantage of this is what you can do. I can, when I'm using an initial template, I can ask for another push of settings. So what I can do is like a one-time update to the service profile by reconnecting it to the template. So I can tell a service profile, associate back to your template. And then it starts that connection again, takes all the settings, and then removes the connection again because it was an initial template. So this connection is active and will stay in place. This is something that is gone, so I do not update my profiles again after I did that initial configuration. But I can say associate with the template, so to get an update of my settings. So this is a more manual trigger for a specific service profile. So that's what I do per service profile, right? And that keeps me a little bit, that gives me a little bit easier overview and a little bit easier maintenance on my servers. Now I can have, I have 3 different templates in the system. So I have a service profile template. I have a VNIC template. And I have a VHBA template. All 3 can be initial or updating. So inside a service profile template, of course I'm going to use one or more VNIC templates to do my work. So if I'm using those VNIC templates in the service profile template, these VNIC templates can be initial or updating as well. And I can have a mix. So I could say that my service profile template is an initial template, but my VNICs that are in this service profile template are using updating templates. Then I can still use the updating nature of the VNIC template even when the service profile template is initial. So I'm going to apply that setting first to the server, and the service profile is going to disconnect from the server, or the service profile is going to disconnect from the template. But for the VNICs, I keep that connection in place, but only the VNICs. So if I change, for let's say, that VLAN allowed list, that checkbox list with VLANs, I make sure that those VNICs will get an updated list of that. Now there are tons of policies and pools that I can set. And I actually just want to demonstrate to you what kind of policies do I set in my system and which ones are necessary to get my things up and running. But technically this is how your templates work, and I will show you a little bit more in detail how it works. Now another thing that you keep in as a setting for your state is of course software. What software version am I running on the BIOS? What software version am I running on the RAID controller of my local disks? What software version am I running on the network interface card, so the Emulex or the Cisco card? There are a number of firmware versions in the blade that also need to be maintained. So inside my service profile template, I also can specify software versions. This is a very easy maintenance tool that I can use to maintain the software on the servers. To maintain that software version on the servers, I create a separate policy specifying exactly for which component, which software version do you use. And that can be a higher version or a lower version. So as soon as I get an RMA for a server, for example, and I am running, let's say, software 205B, for example, when I RMA a server and I get a new one, it's probably going to have 2.1 something installed, or even 2.2 right now. So when I apply the service profile, I applied that with keeping in mind the software version of 2.0. So I want my blade to be downgraded to 205B as well. So all components in the system need to be downgraded. That's something that the software package can do as well. So either an upgrade or a downgrade, it's going to do it for me. And this is the beauty of the UCS system. Software upgrades take time, but it's very easy. As long as you apply the right settings, you just apply them, servers are rebooting, and after a reboot, that takes 20 to 30 minutes, but then the software is at the right version that you want it to be. So cool stuff. Another thing is management access. Management access to the blades means that, of course, the blades need to be managed. What do I use on other servers for that? That's called an IPMI interface, or vendor-specific ones like ILO or DRAC or whatever you want to call them. So there is something that Cisco has that this is doing. And on the C-series servers, that's called the SIMC, the Cisco Integrated Management Controller. In the past, this was called the Blade Management Controller, or BMC. So if you see references for the BMC, that is exactly the same as the SIMC. So pay attention to what you see there. Sometimes, I hope that in 2.2 all the references are gone, but sometimes you still see a reference to the BMC. But most references are now updated to CIMC. Now if I take my blade I run, let's say, my CPUs here. I have a few banks of memory, or a lot of banks of memory. I might have some local hard disks that I install in my server to do things. I have that mezzanine card here, that Palo card in the back. And there's also a special chip that is called the SIMC. Now on the C-Series servers, this is a web GUI. That's not the case in the blades. The SIMC in the blades can only be managed through UCS Manager. So there's no direct HTTP website for that SIMC. The SIMC is always managed through the UCS Manager. So I cannot log into the blade directly. Always go through the UCS Manager. Now what this means is that this part, like if we talk about infrastructure, we have our FEX, we have our Fabric Interconnect, and there we have that special piece, right? So we have the UCS Manager piece, and we have the NXOS piece. Here we have our blade chassis and our blade connected. So let's just take one blade. And as you already know, what we explained about extensively, we have a connection left and we have a connection going right. That port pinning will happen towards a data connection, and that will go into an uplink. Same here, we pin to an uplink, we pin to an uplink, and we go out. Now that CIMC connection here, that CIMC chip in the blade, will only communicate with the UCS Manager. There is a special port here on the FEX, port 9 in our case, that is using that VLAN 4044. That is an internal management VLAN. That's also the VLAN that the SIMC is using, or that can be using the 4047. Either way, it's using an internal management VLAN. This connection is using the same data connection, but it is not going across the data link. This CIMC talks to the management VLAN inside the UCS. So that traffic then reaches to the UCS Manager. So the CIMC talks through a management channel with the UCS Manager and not through the data plane. So the data plane is still fully separated from the SIMC, and that is how it talks with the UCS Manager. Now this implicates one issue. We talked about that management 0 connection here, right? If I want to see the blade KVM, so I want to see the video screen of the server, I want to connect a keyboard to the server, the SIMC supports a thing called KVM over IP. Right, so I can take over the screen, I can control the keyboard just from my local workstation where the server can be in Japan. And I can manage it through IP. I can even support virtual media. So that means that I can mount an ISO image and let it, so the server thinks that I just inserted a CD in the CD drive that it doesn't have. But instead I mounted an ISO on my local image, and that ISO is seen as a CD player in the server. So cool stuff, right? I can do cool stuff with it. The management connection here is using those 3 IP addresses that we talked about. So we have a physical connection for FIA, we have a physical IP for FIB, and we have that cluster address. Now the management port here is not a proxy server, so it's not going to proxy the connections towards the SIMC. So this SIMC will have an IP address that needs to be reachable through the management 0 interface. So the IP address that I specify here on the SIMC, that IP address, I need to allocate that also through a pool or statically configuring it, but it needs to be in the same subnet as my management port, because this management port will have more than 3 IP addresses. So each blade CIMC will get an IP address in that same management subnet. So pay attention to when allocating a subnet for your management IP pool. Pay attention that you take care of your blade IP addresses in that pool. Now there's even a fifth option here, and that is that I can give every service profile its own IP address. So by default, all the blades will get an IP address. But what I can also do is, for example, when I'm using a multi-tenancy environment, I can give the service profile an IP address. And so when that service profile moves from one blade to the other, it's going to take the SIMC IP address and configure it on the other SIMC. So each blade can have 1 or 2 IP addresses for its SIMC. So the physical blade address and the service profile address can be both on the CIMC. When I do not specify a service profile IP address, I'm going to automatically inherit the physical address of the blade itself. And that is something that I need to configure in a pool, or I statically configure it for the SIMC.